Hey, what's up everybody? Welcome to, this is Unit 8, and now we are multiplying fractions. I think you'll find as we get through this that multiplying fractions, I don't know, somewhat, it seems easier than adding and subtracting. And I think possibly it's because we don't have to worry about those common denominators anymore. We can just go ahead and multiply them. We're going to start today though with a simple exercise where we're just looking at we're looking at two things. We're looking at multiplication like repeated addition. So if I'm saying, 4 times 2, I'm saying that I can do 4 plus 4, and that's the same thing, 2 4s, right? Or if I'm doing 4 times 6, I can do the same thing, 4 plus 4, 3, 4, 5, 6, and so on, and that will give me the same answer. Okay, so multiplication as repeated addition. The other thing we're looking at is the associative property, which means that we can regroup things with multiplication, and we'll still get the same answer. So let's take a look at a couple of problems here. The first one's going to be this guided practice up here. So it's saying, do you understand? Explain why 8 times 3/4 is the same as adding 3/4 plus 3/4 plus 3/4. And I think ultimately the big reason and thing that I think about when I do this is that when I'm multiplying, I'm thinking of copies of. I'm thinking on this problem it's 8 times 3/4. What I'm saying is I have 8 copies of 3/4. And so when I think about that, 8 copies of that would be the same here. Addition, I'm asking for 8 copies of those same things, and I'm adding them all up. And that's what I'm looking for. So number 2, go ahead and find and solve, or find 2 times 3/5 and shade this model. So here's our model. I have 2 of them. See, I'm looking at the 2, and I see there's one here and there's one here, so that's 2. And I have 3/5. So there's 1, 2, and that's 3 out of the 5. And I'm shading in these ones. And you can shade them in a little bit nicer. You have a little more control over yours than I do. It's a little bit more difficult to do this on computer. Anyways, I'm shading in my 3/5 and my 3/5. And so I just shaded this in. This should help me solve. If I needed to, I can use my fraction strips on this. And I can see here, well, how many total fifths do I have? I have 1, 2, 3, 4, 5, 6. This answer would be 6/5. And we would break that down because we know that's an improper fraction. But we're not there yet. So, do you know how to do this? Okay, let's find 3 times 2/3 using repeated addition, following the directions. Okay, so I need 3 copies of 2/3. So 3 copies of 2/3. That would be 2/3 plus 2/3 plus 2/3. Okay, and that equals, that's 2/3, and another 2/3 would be 4/3, and another 2/3 would be 6/3. That's a total of 6/3. When you're doing this, you could really think about it in terms of like just almost ignore the denominator here. 2/3, 2 footballs. 2 footballs plus 2 footballs plus 2 footballs. Remember, the denominator here is just expressing the size of the piece, nothing more. 2 footballs plus 2 footballs plus 2 footballs equals 6 footballs, right? 2 puppies and 2 puppies and 2 puppies is 6 puppies. 2 candy bars and 2 candy bars and 2 candy bars is 6 candy bars, okay? 2/3 and 2/3 and 2/3 is 6/3. Easy enough, okay? So 6/3. Now, when we do get an answer like this is an improper fraction, and I think a number bond is the best way to deal this out. 3/3, how many 3/3 are in here? Well, there's 3/3. That's 1 copy of 3/3. 1 copy of 3/3. And if I took away 3/3 from this, that would leave me with another copy of 3/3. I would have 2 3/3. Each one of those is a 1. That's a 1, and that's a 1. And 1 plus 1 equals 2. Wow, easiest math I'll do all day, 1 plus 1. So the answer here is 6/3 or 2. All right, so let's keep going here. Find 6 times 3/4 using the associative property. Okay, so here's how we do this, just like in the visual learning. We're going to take 6 times 3/4. And what we can do is, we can take this 3/4 and we can say that this is 3 copies of 1/4. We just regrouped, and we're keeping that together. We regrouped, and here we go. And so now I'm saying that, you know what, I can now split this out. I can do 6 times 3. The associative property tells me I can do that and still get the same answer. So 6 times 3, so I can do 6 times 3 times 1/4, okay? So 6 times 3 is 18. 18 times, I have 18 1/4. If I have, so 18 times 1, 18 copies of 1/4. And if I wanted to, I truly could write that out I could do this 18 times. I don't really want to do that right now. Bop, 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 so dot, dot, dot. If I did that 18 times, I would do 1 plus 1 plus 1 plus 1 plus 1 plus 1, all the way up to 18. 1 times 18 equals 18 fourths. And that obviously is very improper. So we need a number bond. We need to break this out. How many 4/4 are there in here? Well, let's count by 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then there's 2 left over, 17, 18, 2/4. So this here is 1, and that's 1, and that's 1, and that's 1. This is going to be an important step, that you're able to break these down off of a number bond like this. 1, 2, 3, 4. And I still have 2/4 left over. So I have 1, 2, 3, 4, and 2/4, which looks good, but I'm still not quite done. 2/4 can also be written as 1/2. And so my proper answer here is 4 1/2. And that's what I got. And so let me review this quickly here. What we did was we said to ourselves, well, here's our problem, 6 times 3/4, and we used the associative property to split that out. We said the 3/4 is really 3 times 1/4. Okay, I said 3 times 1/4. That equals 3/4. And you can see how that would be. That's 3 copies of 1/4. That's 3/4, right? And then we use the associative property to just say, okay, well, that means I can do 6 times 3. Because associative property is kind of any order. It doesn't matter to me. I can do it here. 6 times 3 is 18, and 18 times 1/4 is 18/4. So we got this improper fraction here. And we realized that we could just pull out groups of 4/4. We can pull those out. There's 1, that's 2, that's 3, that's 4 groups of 4 we pulled out. We counted by 4s. And ultimately we were left with 2/4, and we add those up. These are 1, 2, 3, 4, and 2/4. 4 and 2/4 could be written as 4 1/2, and we were done with our problem. So 2 different ways to go about doing this. They're leading and building upon each other to give us kind of a finalized step later on down the road here. But ultimately, we can think about multiplying a fraction by a whole number using one of these 2 methods. And so down here, we're going to just do the same thing. We're going to multiply 6 times 3/4. That's 6 copies of 3/4. And so that would be 3/4, and another 3/4, another 3/4, another 3/4, another 3/4, and another 3/4, for a total of 3, 6, 9, 12, 15, 18 fourths on top, 18 of those. And that's 18 times 1/4. Or 18/4, or I need to find my total product here, 18/4. And what I'm going to do is I'm just going to move this over here. That's not a 1, sorry about that. 18/4. And we just did the same thing. We broke it out in our number bonds, right? We got 4 different 4/4, and we got our total of 2 1/2. Okay. Anyway, so you'll see how this works. You're down here. That was the repeated addition method, but then we're asking you to do some of the associative property method down here. So let me run through one of those fast enough for you using our associative property. So we had right here 500 2/5. So if I wrote 2/5 out 500 times, I could do repeated addition. But obviously, we can see now where repeated addition kind of has its limits, doesn't it? I can't really do 500 2/5. That's not going to be realistic. So what I'm going to want to do is say to myself, okay, that is equal to 500 times 2. So I'm going to use the associative property to say that 2/5 is really 2 times 1/5. And then I can do any order now that I have that like that. So I could do this times this. I could do this times this, and then that times that if I wanted to. That's what the associative property tells us, but we don't want to do that. I want to do this because it's easy. 500 times 2. 2 500s is 1,000. Is 1,000. 2 would be 1,000 times, and now I have 1,000 times 1/5. That's 1,000 copies of 1/5. That's even more impossible for me to write out. 1/5 plus 1/5, etc., all the way out. So 1,000, it's 1,000 times 1 is 1,000. over 5. So now, oh my gosh, here comes the tricky part. I have 1,000 fifths, all right? And I can put that here. Let me go back. Let me leave that up. I'll just deal with the mess here. 1,000 fifths. So I have 1,000 fifths. This right here basically is us saying, if you remember, the fraction symbol or the division symbol is a fraction symbol. And I'm saying 1,000 divided by 5 is ultimately what this is here. 1,000 divided by 5. And so I could actually go ahead now and put that into a division. And 5 can't go into 1, but 5 can go into 10. It goes into 10 2 times, and it's 10. And I have zeros, and I can bring those zeros up, and I get my quotient, or my final product here in the end, of 200. And now that is there. All right. And that was an interesting step we took, and we're remembering that fractions really are division. So try this out, repeated addition and associative property. Just give them a shot, see how you do, and we'll see you next time on 8-2. All right, bye.